Hi, in the previous video we evaluated this integral by taking x to be equal to sine theta. Then 1 minus x squared equals to 1 minus sine squared theta, and it is equal to cosine squared theta. And this way we can get rid of the square root. Okay, but what about this one? Here, the formula is this: sine squared theta plus cosine squared theta equals to 1. But if you take x to be equal to sine or cosine, for instance, like here, let's take x to be equal to sine, then this would be sine squared theta minus 1. And from here, sine squared theta minus 1 equals to minus cosine squared theta. So this is going to be the square root of minus cosine squared theta. Minus cosine squared theta. And it is negative. And if you try to use the imaginary numbers, that would not work here, because then it would be I, the absolute value of cosine theta, and I is the square root of minus 1. Okay, and like evaluating this integral, then we're going to have the integral of, and let's remove the absolute value, that would be cosine theta times cosine theta d theta, and with the I here. But then if the integral would be equal to I times this integral, which we evaluated in the previous video, so then the integral of this would be an imaginary function, which is not. You're going to see in a minute that it is not. So the sine and cosines here does not work. But we can use two functions which are called as sine hyperbolic and cosine hyperbolic, and for which this relation exists: cosine hyperbolic squared of x minus sine hyperbolic squared of x equals to 1. I talk about it in a minute, talk about the hyperbolic functions in a minute. But here, for instance, if you take x to be equal to cosine hyperbolic, then this would be equal to x squared minus 1 would be equal to, let's take x to be equal to cosine hyperbolic of z. So would be equal to cosine hyperbolic of z squared minus 1. And from this minus 1 would be sine hyperbolic squared, which is not imaginary. So let's see what are sine and cosine hyperbolics. Sine hyperbolic of x equals to e to the x minus e to the minus x over 2. And e is the Napier number, and cosine hyperbolic of x equals to e to the x, this time plus e to the minus x over 2. And you know, they are like sine and cosines. For instance, the derivative of this, let's calculate the derivative of this. The derivative of sine hyperbolic of x equals to the derivative of e to the x, which is e to the x itself, minus the derivative of this, which is minus e to the minus x, minus e to the minus x over 2. And this is e to the x plus e to the minus x over 2, which is just cosine hyperbolic of x. But you know, the derivative of original sine equals to cosine. Sine of x equals to cosine of x. And this is one similarity. Also, the derivative of cosine hyperbolic equals to sine hyperbolic. Now you could derive it, it's easy. Let me. Now, as I said at first, this relation exists. Cosine hyperbolic squared minus sine hyperbolic squared of x equals to 1. But in sine and cosine, this would be plus. I mean, this was plus, okay? And you know, you actually can prove it. It's easy. I'm not going to do it. And here are more identities. For instance, sine hyperbolic of 2x equals to 2 sine hyperbolic of x times cosine hyperbolic of x, just like the original sine and cosines. Or cosine hyperbolic of 2x is cosine hyperbolic squared plus sine hyperbolic squared of x. But in the original sine and cosines, it was cosine squared minus sine squared. You know, similar. So we also have inverse functions of sine and cosine hyperbolic. Let me derive it. Let's show this as y. Y equals to this, okay? And let's write it as e to the x minus e to the minus x equals to 2y. And this equals to 1 over e to the x. and equals to e to the 2x minus 1 over e to the x. Now I write this as this equals to 2y, and this would be equal to 2y times e to the x. 2y e to the x, and this equals to e to the x squared. Okay, so let's solve it for e to the x. So that would be this minus this equals to 0. And from here, e to the x equals to, no, let me write it here, minus 2y e to the x minus 1 equals to this minus of the coefficient of e to the x, 2y, plus and minus the square root of this squared, which is 4y squared, minus 4 times the coefficients of these two, which is plus 4. The coefficient of this is 1 and this is minus 1, okay, over 2. So, and this would be equal to 2 times this. Okay, so this would be, let's get rid of these two, and these two goes by this, and this is 1. Now, always e to the x for any value of x is always positive, but for y minus the square root of this, you know, here, let me write it here, y squared plus 1 is always bigger than y squared, because it is as 1 bigger than this one. Now, let me so this is bigger than this, and it is the absolute value of y. So here, let me write it. Now let's take to this to this side, or let's subtract the both sides. Let's subtract this from the both sides, so 0 here, and here we're going to have this. Okay, now if y is positive, then this minus this, you know, this would be this, and smaller than 0, but it is equal to e to the x, which is always positive. Right? And what about the negative y? For the negative y, it would be minus y. Okay, which itself is bigger than this is bigger than y minus this, because for the negative y it is negative but it is positive. So again, this is negative, but it should be positive because it is equal to e to the x. So the negative here is not acceptable, and e to the x equals to y plus the square root of this. E to the x equals to y plus y squared plus 1. And now from here x would be equal to ln of y plus, now this is the definition of ln, and then the inverse function of sine hyperbolic of x would be ln of x plus x squared plus 1. Okay, and the inverse function of cosine would be similar to this, except here we have x squared minus 1. And these help us in doing the integration. Now I'm going to first evaluate this integral. Okay, and here you already know the derivative of sine hyperbolic equals to cosine hyperbolic, and the derivative of this equals to this. But what about the derivative of their inverses? You can easily derive it, but I just gave you the final result. The derivative of sine hyperbolic equals to 1 over this, and the derivative of cosine hyperbolic equals to 1 over x squared minus 1. Okay, so in the next video I evaluate this using the hyperbolic functions. Thank you.